So I have shown you a little bit about the video on the reaction between metal and oxygen. So when you react metal and oxygen, okay, you burn the metal, you heat the metal, and then you provide some oxygen. But for this experiment, we don't need to provide the oxygen because oxygen is already 21% in the atmosphere. Okay, so the metal can react with the oxygen to produce a metal oxide, oxida logam. So means that you will get a new substance. This metal easily or not easily react with oxygen to produce metal oxide. Okay, for example, in this video, uh, they did the experiment on magnesium, copper, and iron. Okay, when they heat the magnesium metal, okay, magnesium strip over there, you can see there is a bright flame. Okay, the reaction occurs very fast and it produces a large bright flame. So that one is for the magnesium metal, the magnesium strip. Okay, you can see a very bright flame over here. So the product from the reaction is the magnesium oxide, okay, metal oxide. So you get magnesium metal, you get magnesium oxide. Alright, and then they repeat the experiment using the copper and oxygen. When you hit the copper, you can see just they glows very dimly, okay. Dia berbara dengan malap, dia tak doesn't produce any bright flame, okay. Means that copper is less reactive than the magnesium. You see that magnesium is very reactive, but copper is less reactive. Then the last one they use iron, okay. So you can see a little bit of spark. Means that iron reactivity is intermediate. It is between the magnesium and copper. Okay, from the experiment, it can be said that magnesium number one, iron number two, and number three is copper. So that only for the three metal. But when they try to repeat it using a list of metal, you can see it will provide a different kind of observation. Okay, Ryan's asks, teacher, is it possible to transform the element of the metal to another substance? Okay, for example, it's like it is a magnesium, so you will get magnesium oxide. Okay, if it is copper, you will get the copper oxide. But when you heat, for example, like magnesium and iron oxide, magnesium can replace the iron to become magnesium oxide. Another one, you leave the iron only itself. But that one is a good question by Ryan, but that one is the syllabus in chemistry form 4 lah. Okay, there is a possibility that some of the element can replace the element inside the compound, but inside the substance. Okay, but that one you don't need to worry about. Okay, but it's good for you for the next level. But for our level, for PTT level, they heat the metals, and you will see a different kind of flame, a different kind of reaction. So if we see magnesium, it burns very quickly with a very bright flame. So it is number one, magnesium on the top, and then followed by aluminium, it's just bright flame. Zinc moderately, iron burns slowly, tin it just glow, not burns, it glow brightly, but copper glows dimly. So this is the position of the metals in the metal reactivity series. So the top one is the most reactive, the more reactive, but the bottom one is the less reactive. Okay, so this one actually we already learned it last week. Okay, alright. If you watch cartoon Avatar, you can metal bender. So now you already learn about the metal reactivity series. You are the beginner of the metal bender. Once we go to more topics, you will become intermediate and lastly expert lah. So just now is the beginner, you are the metal bender. Okay, alright. For the next one, what you want to learn is the position of carbon and hydrogen. So this the list just now is only for the metals, but beside metals, carbon and hydrogens are also reactive. They also can react with another substance, but somehow because of carbon and hydrogen are not metals, they are not put inside the reactivity series of metal. But actually, they can react with what we call with another substance too because they are reactive. So why we want to learn about carbon hydrogen? Because carbon and hydrogen are among the most available uh, substance in the earth. So senang nak cari. So kita nak tengok ke manakah kedudukan carbon dan hydrogen dalam siri rectifier ni. Okay. So kita first kita tengok dulu untuk carbon. Okay. Untuk carbon, how they want to know the position of carbon in the reactivity series, they do the experiment called as reducing metal oxide with carbon. It means that you mix metal oxide and carbon in a crucible and then you heat it. So when you see there is a reaction, maksudnya you nampak tindak balas, there is a reaction, means that the carbon can replace the metal from its outside, from its metal outside. So maksudnya carbon steal the oxide from the metal outside. So when it steal the oxide, it become carbon dioxide. It just leave the metal alone. So kalau carbon tu boleh buat kerja, carbon can replace means that carbon is more reactive than the metal. Okay, so the position of the carbon is on top of that metal. But when there is no reaction, at all, when you mix the carbon and the metal oxide, means that the carbon position is below that metal. Okay, means it's below than the metal. So when we can know the position of the carbon based on the reactivities. The possibility for the carbon to replace the metal from its metal oxide or not. So okay, this is the example of the experiment. Okay, when you mix the metal oxide with carbon. So in this experiment, they don't have the crucible and they just use the what we call it, the cap of the bottle, the ceper that sudah dah gantikan crucible tersebut. Then you wet some carbon powder. Okay. Then you take also, so in this experiment, they use copper oxide. Okay. They mix carbon and the copper oxide. Okay. And after they mix it, they will put on the crucible, sorry. Okay. And then afterward, you will heat it. So when you heat those kind of mixture, you will see there is a reaction or no reaction. So for copper, this is the result. You can see a little bit of the flame. Okay, you can see there is a flame over there. So it means that carbon can replace copper from the copper oxide. Carbon is more reactive than the copper. So that's why carbon can steal the oxide from the copper oxide. So the result, the product that you will get is the copper metal and carbon dioxide because carbon already take the oxide from the copper oxide. So it becomes the carbon dioxide. And then it just leave the metal alone. It just leave the copper alone. So because of the reaction is not finished, you can see two different colors. One about the black colors and another one is the brown color. So the black colors is the excess carbon, and the brown color is the copper metal. So copper metal is the one inside the wire, right? The wire electric kan nampak macam warna-warna keperangan. That one is the copper. So in this experiment, they get the copper metal alone. Okay. And then this is another set of experiment. They use iron oxide. Okay, they use ferrum oxide, besi oxida. So besi oxida, ferrum oxide, you mix with carbon and then you heat those mixture. So you cannot see the obvious reaction, but actually there is a little bit flame from the reaction, but you cannot see it clearly from here. But it's okay. But we know that if there is a reaction, carbon will take the oxide from the metal, from the iron oxide. So it become carbon dioxide. It will leave the metal alone. So in this case, we will get the iron metal. Kita akan dapat besi yang tulen. We will get the iron. Okay. Okay, they test the iron with magnet. So magnet is only can react with the pure iron. So means that the experiment is successful to get the pure iron. Okay. Another conclusion from here is that carbon is more reactive than the iron. So that's why carbon can steal the oxide from the iron oxide. So from the experiment, we know that carbon is above copper and iron in the reactivity series. Okay, besides that, if we repeat the experiment with another kind of metal oxide, such as aluminum oxide, zinc oxide, lead oxide, copper oxide, you will get a different observation. For example, like aluminium, we will not see any kind of reaction. There is no reaction. But for zinc, lead, and copper oxide, you can see the mixture glows brightly. So it means that carbon, there is a reaction in zinc, lead, and copper. Means that the carbon is more reactive than those three metals. But carbon cannot steal the oxide from aluminium because aluminium is more reactive than the carbon. Carbon is less reactive than aluminium in this case. So from the experiment, we can conclude, we can summarize that carbon is placed between the aluminium and zinc in the reactivity series. So if you go back to the reactivity series, you can see that the position aluminium and zinc is nearby to each other. Aluminium on top, above, zinc is below. Zinc is below aluminium. But after this experiment, you know that carbon take the place between the aluminium and zinc. So this is what the experiment want to do. They want to know the position of the carbon. Right? The same experiment is repeated but using hydrogen to replace carbon. So if you use hydrogen, hydrogen will react with the metal oxide. Okay, hydrogen will steal. Dia akan ambil oxide from the metal. Okay, hydrogen and oxide. Hydrogen oxida, hydrogen oxida. Hydrogen and oxida will form water. So you get a water vapor. Then you will leave the metal alone. Okay, because the hydrogen is already take the oxide from the metal oxide. So we'll get the product is metal and the water vapor. Okay, same like carbon before this. If the hydrogen is capable to do this reaction, it means that hydrogen is above those metal. But if the hydrogen doesn't able to steal the oxide, means that there is no reaction. It means that hydrogen is below that metal. So this is what the experiment want to do. They want to know the position of hydrogen in the reactivity series. But in this case, hydrogen is in the gas form while carbon is in powder form. So you cannot mix it directly like what we mix the metal oxide and carbon. So in this experiment, we need to heat the metal oxide and at the same time you put the hydrogen gas inside the tube that will flow towards the test tube that contain the metal oxide. Okay, so this is the experiment done to show the reaction between hydrogen and metal oxide. So in this experiment, they will use iron oxide. Okay, this is the iron oxide ataupun nama lain kita adalah hematite. So hematite, if we go back to what we learned last week, hematite is the mineral for iron oxide. So if you test iron oxide with with magnet, the magnet will not it's not capable to attract the iron oxide. But for the pure iron, you can easily get it. Alright. But afterward baru magnet tu boleh ambil iron oxide tersebut. Okay? But they just react with the pure metal. It doesn't react with the iron oxide. So this one, you will burn some of the chemicals to produce hydrogen gas. Okay, the hydrogen gas will be disalurkan ke dalam tube ni, alright, and then will go to the test tube. Okay, the white one is cotton wool, and then this one is the iron oxide. So if you test iron oxide with magnet, the magnet cannot pull the iron oxide. Okay, but when you heat the iron oxide with the presence of hydrogen gas, you will see a reaction. Okay, the powder turn from the brick red color to black in color. It means that you get the reaction. So this one is ferrum O3 is iron oxide plus hydrogen gas. You get iron ferrum only plus water. So you can see water vapor inside this small tube over here. This is the water vapor. So this experiment show that hydrogen is capable to take oxide from the iron oxide. So it means that hydrogen is positioned above the iron in the reactivity series. Alright. Okay, same thing like carbon case. So this experiment is repeated using the different kind of metal oxide. For example, like zinc oxide, iron oxide, tin oxide, and lead oxide. So they did the reaction and then observe what is the result. So when they test with the zinc oxide, there is no reaction. But for the iron, stannum, tin, lead, you will see the powder burns brightly. So when there is no reaction, it means that the hydrogen is less reactive than zinc. Okay, zinc is more reactive than hydrogen. That's why hydrogen cannot do anything. But when hydrogen is stronger, is above the metals in the reactivity series, they can uh, they can take the oxide from the metal oxide. So from the experiment, we can conclude that hydrogen is placed between zinc and iron. So we know the position of hydrogen from this experiment. So okay, to make this table, this series easily to be looked at, I put the carbon and hydrogen into the reactivity series. So this one is the complete reactivity series of metals. Semua logam yang kita dah belajar tadi, then plus carbon and plus hydrogen. So if you want to memorize the reactivity series, so this is the complete one because it already include carbon and hydrogen. So it is better to use this complete reactivity series. Okay, and then you need to know that carbon is positioned between aluminium and zinc, while hydrogen is positioned between zinc and iron. Alright. Okay, any question about 4.2 for the reactivity series? Before we move to the next subchapter, 4.3. So this is all about 4.2. You just need to know about the metal reactivity series. And then they did some of the experiment to know the position of carbon and hydrogen in the reactivity series. Okay, any question about this? 4.2. So now you already learned and know the complete reactivity series. So now you are already intermediate level of metal bender. So you can bend more metals. Before this, you just the beginner, just a little bit of metal. But now you are already intermediate. Okay, so we continue to the 4.3, the extraction of metals from their ores. Okay, most of the metals, they cannot exist in the element form. Dia macam dia tunggal dia sahaja. But most of the metal exist in the mineral form. And then this mineral, we call it as the ore, biji. Okay, ores. Okay, but some of the mineral also, they can exist in the element. So it depends on the position in the reactivity series. So that's why we learn about the reactivity series. So in this chapter, you will learn about the extraction, which is you want to get the metal from its ore. You want to get the pure metal from its mineral, from its natural compound. So we already learned about all of these minerals. So if you remember again, bauxite. Okay, bauxite is aluminium oxide. Okay, so inside bauxite there is a aluminium metal. So human, they mine the bauxite in order to get the aluminium metal, to get the pure aluminium metal. So bauxite, you can get aluminium. So hematite is iron oxide. So kita lombong hematite ni, kita nak dapatkan biji, kita nak dapatkan besi tulen. So we mine the hematite to get the pure iron. Cassiterite can be extracted to get pure tin. Galena can be extracted to get pure lead. Okay, and then malachite can be extracted to get copper. Okay, this 5 is the natural compound. Compound means there is 2 elements inside that. Okay, but we want to get 1 element only from that compound. So what we need to do is to extract from them. So from this 5, you can get this 5 pure metal. But somehow, some of the metal, they exist in natural element. So maksud dia kat sini, dia tak bercampur dengan sesiapa, dia hanyalah dia sahaja. It is exist in the element form as a lone. Okay, dia tak bercampur dengan unsur lain. So most of this can be found in the natural element form. So kita dah belajar dulu pasal unsur semula jadi about the natural elements. We have the example such as gold, silver, platinum, and mercury. So these 4, if you mine, kalau lombong, will not get the minerals yang campur-campur macam ni, but you will get it already. Okay, get the element form. So senang lah, tak payah nak extract susah-susah. So yang 5 ni dah lombong, and then you kena extract. But for example like gold, silver, just lombong and then bersih-bersihkan sikit, you get already the gold, silver, platinum and mercury. Okay, so actually the method of extraction depends on the position of the metal in the reactivity series. If you notice, gold, silver, mercury, platinum is on the bottom layer of the reactivity series. So means that they are not reactive. So when they are not reactive, we are easily to extract them. Maksudnya kita lagi senang nak extract dia, tak ya? Susah kalau dia kat bawah. Tapi kalau dia kat atas, more reactive, This is harder to extract. Why? Because they are reactive. They want to get another substance to attach. Dia nak bergabung dengan substance lain sebab dia sangat-sangat reaktif. So kena ambil method yang lebih susah untuk nak mengasingkan this kind of ore, this kind of mineral. Nak mengasingkan dia punya besi atau logam daripada biji dia lah. To extract the metal from the ore is a little bit harder when the position of a metal is on the top of the reactivity series. So it depends on the position of the metal in the reactivity series. So this is the summarize how you want to extract the metal from the ore. Okay, it depends on the position of the metals in the reactivity series. Okay, for potassium, sodium, calcium, magnesium, and aluminium, they are above carbon in the reactivity series. So it means that we cannot use carbon to extract them. So there are other methods to extract them by using the electrolysis of metallic compound in a molten state. Okay, electrolysis means, okay, electro means electric, lysis means break. So means that kita pecahkan, kita break down the ores, kita break down the minerals menggunakan tenaga elektrik. We break down the ores, the metallic compound ni using the electric. But it can be done just in the molten state. Means that you need to heat up the metallic compound first. You need to heat up the compound until it melts, and then afterward we do the electrolysis method. So if you remember, we learned it in chapter 5 from 2, the electrolysis of water. So the electrolysis of water, they put the electricity, then put the wire, positive and negative, to the inside the water. And then they collect what is the product for both terminal, positive and negative. And then you see there is like gas collected, which is hydrogen gas and oxygen gas, because water is H2O. It's made up of from the hydrogen and oxygen. So if you use electrolysis, it breaks down the water into oxygen and hydrogen. So it is the same concept they want to apply here. So for example, you have aluminium oxide. So you heat up the aluminium oxide until it melts, and then you use electricity, you use electrolysis to separate the aluminium and oxygen from the aluminium oxide, because inside the aluminium oxide, the elements exist are aluminium and oxygen. It means that you want to break down the bigger part into the smaller part. The smaller part is the elements, which are the aluminium and oxygen. So you need to use the electrolysis method. So electrolysis is a little bit high cost because you need a lot of heat and a lot of electric. Okay, Ryan asks, teacher, is there a manual way to break down the water to oxygen and hydrogen instead of using an electrolysis? So for water, only the electrolysis method can be used to extract the means that to break down the water to oxygen and hydrogen. So there is no other manual way to do that. Electrolysis is the only way to show the composition of water. Okay, alright. That one is for the metal above carbon. And then metal below carbon, there are three different methods. The first method is the reduction of metal oxide by carbon. So this one can be applied for zinc, ferrum, tin, and lead. Okay, this one, the reduction of metal oxide by carbon, is the one that I already showed you before the video. The one that you mix with the carbon powder, the metal oxide, and then the carbon will steal the oxide from the metal oxide. You get carbon dioxide and leave the metal alone. So this is the concept that they applied in order to extract zinc, ferrum, tin, and lead. So that's why we learn about the position of carbon. Since carbon is more reactive than these four, so that's why we can use carbon to extract those. Okay. Okay, electrolysis also can be applied for all potassium until copper. But electrolysis is quite pricey, maksudnya mahal. So kita boleh guna cara yang lebih murah iaitu reduction of metal oxide by carbon. Okay. So this for the zinc, ferrum, tin, and lead. Okay, but some of the metals you can easily heat them, and then the when you heat them, it will break down into the elements easily. So this one can be applied for copper and mercury. But mercury sometimes also they exist in the elements. So for mercury, silver, and gold, it exists in the form of elements. So means in the natural way, it already purified, it already extracted. Okay, we don't need to extract because it's already extracted. It's already exists in the form of elements. Means that just alone there, just one element inside there for gold, silver, platinum, and then mercury also. So it is easy. You just need to mine lombong, find them, and then just do some clean up a little bit to get the metals ready. But others you need to do another method such as electrolysis, reduction by carbon, and heating it. Okay. Alright. So this is the only method, the four method that can be used to extract the metals. So you need to remember all four methods and what are the examples of the uh, metals that can be extracted using that using the certain method dia lah. Uh, in detail, we will learn about the reduction of metal oxide by carbon after this for the next class. Okay, for this class, I will show briefly how electrolysis, reduction by carbon, heating, and the last one, the form of elements in the video. Okay, for the next video, it's just the additional information for you. So you don't need to remember for the exams, okay? But we learn about this four method after this, just for your additional information. So uh, you can look one by one. So for the first one, for electrolysis, so I take aluminum oxide as example. Okay, they want to extract the aluminium from the aluminum oxide using the electrolysis method. So this is using the electricity to extract them. So beside electricity, you will use heat also because you want to melt the aluminium oxide. Okay, aluminium can be used in many applications. Okay, aluminium. The mineral for aluminium is bauxite. When you purify the bauxite, you will get aluminium oxide. Okay, aluminium oxide is the natural compounds for the aluminium. But now you want to get the aluminium metal only. You don't want the aluminium oxide. You want to get the pure aluminium from the aluminium oxide. So what you need to do is the electrolysis method. So in this electrolysis method, okay, they will put inside a tank, okay, a very big tank. Okay, this is the tank that can be used to extract the aluminium. So what you will have here, you will melt the aluminium oxide, and then will when you melt it, it will be separate into the aluminium ion and oxide ion. So don't worry if you don't understand about this yet, because this one is form 4 chemistry punya level lah. Okay, so but basically you will have electricity here. So this one at the wall here, you will have negative terminal, and then over here, the plus one here, you will have the positive terminal. Okay. When you turn on the electricity, aluminum ion will be attracted toward the negative terminal, but oxygen ion will attracted to the positive terminal. So this is how you want to separate the aluminum from the oxygen. Okay, see, aluminum all go over the negative terminal, you will get the pure aluminum over here. But then you just collect it because aluminum is denser, you collect it in this area. While oxygen ion will go to the positive terminal to become a carbon dioxide. Okay, so this is about the electrolysis. But this one is a very expensive method. So that's why aluminum is a little bit as expensive. Okay, this one is for aluminium. Okay, the next one is for iron. Okay, for iron, the method that we can use is the reduction by carbon. So iron, you take the iron oxide, the ores there, and then you mix with the carbon, and then you heat up using high temperature. Okay, so this is the video to show the extraction of iron from hematite. Hematite is the mineral for iron oxide. So this one is you have hematite, okay, iron oxide, but two only. This one magnetite is iron oxide too, but got three iron inside this. But for your for PT3, we just learned about the hematite. Okay, in this method, they will have a very big blast furnace. Kita namakan dia sebagai relau bagas, the blast furnace. And then you put carbon in the coke form. Kita panggil dia sebagai arang coke lah, coke. That one is the meaning of carbon over here. And then you mix with carbon with the iron oxide. Okay. And then you put gas to the fire to heat up the carbon and the iron oxide at a very high temperature until it melts. So inside this one, the reaction will cause carbon to steal or to take oxygen from the metal oxide, become a carbon dioxide, and you leave the iron oxide alone, the metal alone lah. Suhu dia boleh mencapai sehingga 2000 darjah Celsius. Okay, very very high temperature if you want to use this method. So this is the formula for the process: iron oxide plus carbon, but this one carbon in the form of carbon monoxide. So carbon monoxide, it will steal the oxygen from the iron oxide. You will leave the iron only. Then you will get the carbon dioxide. So it's now you can get the pure iron. You can get the iron from this method. Okay, besides that, there is some waste such as sand and then soil inside the ores, inside the hematite, right? So that's why they want to remove also all the waste. They're using the limestone, the calcium carbonate. It will react with the waste to form a slag. Slag means the waste product from this kind of reaction. So this one, this one is the slag. Okay, slag is the product from the limestone and the sand and soil. So this one we don't want it. We just want the pure iron. So but this one you can collect it because it can use as a foundation for buildings and roads. Jalan-jalan tar tu. So at the bottom layer you will get the iron. So the iron is denser, that's why it's on the bottom layer. So you will get the iron from this method. But somehow the iron is not pure. You will have a different kind of iron depends on the composition dalam dia lah. So for this method, you will just get the pig iron because it doesn't pure, but it can be used to make the cast iron and steel afterwards. Okay, but this one very detailed. So you don't need to know to remember this, but you just need to know for your information. But uh, for this extraction about the blast furnace, we will learn in detail for the blast furnace in the next class. So you will know about the reaction happen inside the blast furnace. Yang relau bagas yang besar tadi tu, you will learn about all the reaction and what are the uh, reactant and product. Apa yang ditambah kat dalam tu, apa produk yang you akan dapat. So that one you will learn in detail for the next class. Okay. Okay, the next one is the copper pula. Copper tadi you guys learn copper we just can heat the copper and then afterward you will get the metal. So in this experiment, detect the malachite. Okay, for okay, wait Ryan asks, teacher, what metal substance contained in stainless steel? So stainless steel, you have iron, and they put some carbon inside to make the steel stronger, harder, and not easily rusting. So they put some carbon inside the iron. Stainless steel is the combination of iron and carbon. Okay, Ryan? Alright, the next one is about the copper. So copper, okay, you see this one about the bluish color powder here. So this one is the malachite. So malachite is the mineral. The scientific name of malachite is copper carbonate. Okay, dia ada copper, dan dia ada carbon, dia ada oxygen dalam malachite tersebut. So malachite is a copper carbonate. So when you heat up the copper carbonate, heat up the malachite, you will get copper and carbon dioxide. Because, okay, this one, carbonate being released from the heating to react with oxygen to produce carbon dioxide. And then you will get, wait, also carbon dioxide. So the lime stone water here can be used to detect the presence of carbon dioxide. It will turn cloudy. So this one you already learned before this, right? About the cloudiness of the lime water when you test with the carbon dioxide. So this is very easy. You just need to heat up, you will get the carbon. So if you notice just now, the color of malachite is like a bluish in color, but when you heat up, you will get the brownish blackish color. The one is the copper. Okay, so this one copper is very easy. Just need to extract. Sorry, we can extract the copper by just heating the or eating the malachite. Alright, but the easiest one is the one that can exist in the element form. For example, like silver, mercury, platinum, and gold. So these four exist in the natural element. So if you find this in the soil, you can get the metal ready or easily. Means that they are dah betul-betul tunggal sebagai logam, bukannya campur dengan bahan-bahan lain. So dalam video ni, inside this video, they do some gold planning. Gold planning ni adalah mendulang emas. So they go to the river area, about waterfall area, and then just take some of the soil from inside the river and you do some panning and then pusing sikit, it makes the gold is denser, so it will stay at the bottom. And all others such as sand, soils, and any other waste, it will go, will bring away from the quarry tu. Just tinggal emas saja dekat bawah. So this is what the gold panning method is about. So you will get easily. Yes, Danish. Tak faham yang mana, Danish? Okay, there is no sound, but you can find the sound when I give you the video. Okay, don't worry about the sound. You can see the video again. I will give you the link. But for the class, I will not give you the sound because at the same time I want to explain this. As you can see, the golden color there, that one is the gold. So no need to be extracted afterward. You can just map it to make what form do you want. So emas tu dapat dengan senang. So emas tu dia kata daripada kawasan atas, dan air terjun dia akan bawa turun ke bawah. Ini adalah contoh hasil apa yang diorang nampak, diorang dapat daripada mendulang emas ni lah, gold panning. So dekat Malaysia ada juga kawasan mendulang emas dulu-dulu macam dekat Sungai Lembing, Pahang. So you guys learn geography. Yes, this is a real gold. Kat Malaysia pun ada, kalau ada orang pernah pergi dekat kawasan sungai, kat dalam hutan-hutan tu, you guys pergi bawa kuali dan ambil pasir dia, buat some gold panning, mendulang. Okay, nanti dapat emas yang kat bawah tu. That one is the real gold. Tapi dekat Malaysia emas dah tak banyak dah. Dulu kalau dulu kat Pahang tu ada banyak lah juga emas. Ramai juga orang pergi mendulang emas, dia nak cari emas tersebut. So kalau you belajar geografi, ada tempat-tempat yang ada banyak emas kan. Sungai Lembing, Pahang, ada beberapa tempat dekat Selangor, Perak. But now benda tu dah kurang, tetapi masih ada. So kalau nak pergi ke hutan-hutan tu, ada barangkali yang nak cari pun ada juga, tapi dah tak banyak lah, susah. Cuma dekat Alaska kan tempat yang remote area, maksudnya tempat yang terpencil, tak ramai orang pergi kat sana. So banyak lagi sumber-sumber mineral yang masih ada di sana. So that one dia orang nak carilah. So ni adalah contoh. Nak bagi tahu yang gold ni dia wujud secara semula jadi sebagai metal. Dah, dia tak dicampur dengan yang lain. Gold is already exists in the element form. They are not compound. So you don't need to do extraction method in order to get the metal. Don't need to extract in order to get the metal. This is applied for gold, silver, mercury, and platinum. Okay. So for this class, what I want you to remember is these 4 methods and what are the example for all. What are the example of metal for all the methods? For example, electrolysis can be used to extract what? Reduction of metal oxide by carbon can be used to extract what kind of metal? And then heating up only can be used for copper, the elements for mercury, silver, gold, and platinum. Okay, next question I can ask teacher, what are the other elements that can be mixed with gold to make it a compound? So gold doesn't react with any elements because gold is positioned at the bottom of the metal reactivity series, means that they are least reactive. Okay, they are not reactive at all, they cannot react with another. But silver, yes, they can act, for example, with oxygen to get silver oxide. But gold, since this is at the bottom, gold and platinum, it doesn't react with the other elements to make a compound. So that's why we cannot see at all gold oxide or whatever, gold carbonate, tak ada kan. Because gold they exist dalam unsur sahaja, but they are not reactive. Dia tak boleh bertindak balas dengan bahan lain sebab dia tak reaktif. Kalau yang atas ni dia lebih reaktif, sebab tu dia nampak compound lain. Okay, is there any question about this chapter? That's all about the about this chapter. So if you have any question, you can ask. Okay, Danish asks, why gold did not exist to be compound naturally like others? Okay, because gold is the least reactive. It's positioned at the bottom layer of the metal reactivity series. It doesn't react with other substance because dia tak reactive. Okay, but if you know in detail actually, inside this you will learn about the electron, proton, neutron inside the metals and what makes them reactive and what makes them not reactive. But for your level, you just need to know the reactivity series, okay? And then you need to know what are metals reactive, what are the metal that is reactive and doesn't reactive. Okay, gold doesn't reactive, so that's why you cannot find any uh, gold compound naturally. Gold compound naturally. Okay. All right. Any other question? So now you already know a lot of about metals, the activity series, about the metals. So now you are already expert in the metal bender. As a group, you can perform a artistic metal bender such as in the diagram ni, such as in the slide ni lah. Okay, for the next class, we will learn about blast furnace. We will learn about how to extract iron and tin from the compound, from the natural compound, using the method reduction by carbon. Alright, as usual, you need to do the module page 46, 47, and 48, and I will provide you the link for the quiz. So you need to answer the quiz before 2 p.m. tomorrow. Okay, don't forget 2 p.m. tomorrow. Okay, there's any more question? Expensive element in the world. So expensive element in the world, mostly the one that can form in the crystal form, yang wujud secara bentuk kristal. For example, like diamond, okay, nilam, sapphire, habis ada apa lagi ya? Zamrud. Okay, semua-semua tu adalah mineral yang biasa, tapi kalau dalam keadaan orang panggil suhu dan haba tekanan yang terlampau tinggi, dia akan menyebabkan mineral tersebut tersusun dengan sangat-sangat cantik, dia akan membentuk kristal. Okay, so kristal bila jadi kristal, memang dia jadi sangat mahal. Okay, for example like diamond. Diamond is one of the most expensive element in the world. Diamond is just a carbon actually. But because of the carbon, atom is positioned very uniformly because of high temperature and high pressure, it turns from the carbon into a diamond. So kalau tengok carbon tak berapa nak berharga, tapi bila jadi diamond dia sangat berharga. Sama juga macam pearl, mutiara. Dia sebenarnya pasir je. Tapi disebabkan dia dah dalam tiram oyster, dia dah ada tekanan yang tinggi, dia tersusun cantik kat dalam tu, dia jadi bentuk yang cantik, dia jadilah mahal, jadi pearl. Dia jadi bentuk yang mahal lah pearl. Macam nilam, sapphire is a copper actually, kuprum je. Tapi sebabkan dia haba dan tekanan yang tinggi, dia wujud secara kristal, dia jadi mahal. So actually, crystal form of the mineral is the most expensive element in the world. And one of the example is the diamond lah. Diamond, dia ada sapphire, nilam, zamrud, emerald kan. Dia apa yang merah tu? Delima, emerald. Contoh-contoh lainnya yang mahal. Kalau wujud secara kristal memang dia sangat mahal. Okay, lagi ada soalan? Tak ada, cuba ambil attendance. Okay, Danish, Asmita ada. Diana ada, Diana. Diana no, Hana no. Ini yes. Iman yes. Joshua yes. Kuhan yes. Go ahead. Yes. Norvegia. Yes. Nurin. Yes. Pavin. There is no Pavin, right? Taif. Ryan. Sharanya. No. Tanush. Yes. Vaishnavi. Yes. Vibhushan. No. Jasmine. No. Okay. Then. So if you have any question, you can PM me personally. I will try to ask your question. Okay. Don't forget to do the quiz in the module. I hope that you understand this method. It's just very easy about the carbon and hydrogen, where are their position in the reactivity series. And another one, how you want to extract the metal from the metal from their ores. Okay, there are four methods: electrolysis, reduction by carbon, heating, and the one that already exists in the element form. So that is the only part that we want to learn today. Alright, is there's more any question? Okay, we finish the class. Thank you very much. See you next Thursday. Bye.
Thank you, teacher.
Bye. Welcome, welcome.
Thank you, teacher.
Thank you, teacher.
Okay, bye, Tanush.
Okay, bye, teacher.